Okay, Chapter 6, Section 4, I split into two parts. It's considered factoring polynomials. The way the book has it laid out, I'm not a fan of, so I'm going to go ahead and do notes that are not found in the book. But you will have worksheets for homework for both of these parts, and then the book work will come on Friday if you read the agenda. So, factoring polynomials. So it's kind of when you factor, you technically divide, but you divide out what is common within the polynomial. So when you're factoring, you're technically dividing out. And the biggest thing you need to know how to do first is how to factor out that greatest common factor, or just the common factor. You should always check for a greatest common factor, a GCF, first before you do any other factoring methods. So we're always going to take out the lowest exponent, because we can't take 3 out of 1. So if we had just an x, but we had an x to the third, you can't take 3 x's out of 1 x. So you have to just factor out an x. So if we look at this first example where we're factoring out just the greatest common factor, we have x to the third plus x squared plus x. I want to factor out that common factor. Well, I can't take 3 x's out of 2, and I can't take 3 x's out of 1. So this is where that lowest exponent always comes into play. I'm going to just factor out an x. So when you factor something out, you're going to write it out. So we have x, and then I'm going to open up a parenthesis. So this is what I've factored out. This is my greatest common factor. So then I'm going to just go ahead and divide each piece. So x to the third divided by x. You remember, you subtract your exponents when you deal with division among monomials. So 3 minus 1 is going to leave me with an x squared. X squared, and I'm going to factor out an x out of that, so I'm pulling out an x. That's going to leave me with an x, and I'm following the sign. And then when I pull an x out of an x, I'm still going to have something there. I have to have that placeholder, so it's going to be a 1. So that would be this completely simplified. I'm going to pull out an x, and then I'll have x squared plus x plus 1 left. Okay? And then for the second example, for factoring out the greatest common factor, numbers can be involved as well. So I have 5x squared plus 25. So looking at this, I can't pull out an x because this term does not have an x. In order for you to be able to factor it out, every single term has to have it. So I cannot pull out an x because the 25 does not have an x. However, if I look at the numbers, 5 and 25 have a common factor. So I can pull out a 5. So I'm going to pull out a 5. I'm going to open up my parentheses. 5 divided by 5 is going to leave me with 1. So I'm just going to have that x squared. 25 divided by 5 is 5. And that would be as simple as you could do that. So pulling out the greatest common factor is the first step in factoring. It's the easiest thing to do. Always check for that greatest common factor. Always take the lowest exponent. Remember, you can't take 3 out of 1. When it comes to numbers, or you could pull out numbers and variables, make sure in order to be able to pull something out, yes, this has an x squared, but this has to have an x or an x squared as well. Okay. The next step in factoring is factoring by grouping. So this happens when you have 4 terms. So you group when you have 4 terms. In order to do this, we have to have those 4 terms. The first step is we're going to factor out a GCF. So if I look at 240, 90, 275, all of those end in a 0 or a 5. So I'm going to say my greatest common factor is 5. Because 75 does not go into 90, so I can't pull out a 75. 25 does not go into 90. So you got to think about your factors and say, what is going to be the greatest number that I can divide evenly into each of these numbers? So again, I'm going to go with 5. I cannot pull out an X because it is not here with the 75. So my first step, I am just going to pull out a 5. So 240 divided by 5 is 48. I'm still going to have that X cubed plus 90 divided by 5 is 18. Still going to have that X squared plus 200 divided by 5 is 40. Still going to have that X. And then 75 divided by 5 is 15. Okay, now if I look at this, 48, some factors that come to mind are 8 and 6, 48 and 1, 18, there is no way with 8 and 6 that I could get the same. I could probably factor out a 6 between both of these, but I can't factor out a 6 here. So that means that we did something right. So if you can still pull something out once you already factor out what you thought was the greatest common factor, if you can still factor something out of each of the terms, go ahead and factor that out as well. Maybe that number didn't come to your head. And then you would just multiply it to your first factor that you have. But in this case, 5 is the greatest common factor. From there, I'm going to form 2 groups. So I have my 4 groups. This 5 is just kind of tagging along. He's not important anymore until the end. So now I'm going to form 2 groups. So within these parentheses, I'm going to say the first 2 terms I'm going to group together, and I'm going to group together the second 2 terms. I then want to factor out the greatest common factor of each group, because like I said, these 2 have a common factor. These 2 don't have the same common factor. So I'm going to go ahead and pull out the greatest common factor here. So I have a number and a variable. So the lowest variable I have is x squared. So that's going to be part of my greatest common factor. And then between 48 and 18, I can factor out a 6. So I'm going to pull out 6x squared. That was my greatest common factor. That 5 is just going to tag along from before. So I'm going to pull that 6x squared out. 48 divided by 6 is 8. X cubed divided by x squared is just x. 18 divided by 6 is 3. X squared and x squared, it's just going to stay that. So I have 8x plus 3. When it comes to the 40 and the 15, I can factor out another 5. So this is a plus sign. So that means I'm going to carry that down. And I'm going to factor out a 5. So when I do that, I'll have 8x. 40 divided by 5 is 8x, and there's no other x. And then 15 divided by 5 is 3. These 2 sets of parentheses should match. This and this should be the same. So if they are the same, you did the problem correctly. So 8x plus 3 and 8x plus 3. So I'm going to technically factor that out. So again, this 5 is going to just chill. And I'm going to say 8x plus 3 is going to come out. So I'm factoring that out of this whole thing. Once I do that, that leaves me with these 2 greatest common factors. So I'm just going to throw them in a set of parentheses as well. And that is your final answer. You have 5 times the quantity of 8x plus 3 times 6x squared plus 5. And then you go to close your parentheses. So this is your final factored answer. Just in case you didn't see it. So we factored. This is everything here. Let's do another one like that. So I have 20a to the third minus 28a squared plus 5a minus 7. So out of this, I'm going to check for my greatest common factor first. So 20, 28, 5, and 7. 5 and 7 are prime numbers. So that means that they're going to pretty much have 1 and itself. Meaning 5 or 7 cannot both go into 20 or 28. Like it cannot, 5 cannot go into 28 evenly. 7 cannot go into 20 evenly. So with this, there is no greatest common factor. So we checked for it, it's not there. I'm going to go ahead and set up my two groups. So I have 20a to the third minus 28a squared plus 5a minus 7. I'm going to factor out the greatest common factor out of this first group. So looking at 20 and 28, I can factor out a 4. Looking at a cubed and a squared, I can factor out an a squared. 20 divided by 4 is 5, and that's going to leave me with an a. 28 and 4, I'm going to have a minus 7, and the a squared is going to stay there. Now here, again, we can't really factor anything out except for 1. So I'm going to pull out a 1. And that's still going to leave me with the same thing, 5a minus 7. So again, if we look, these parentheses are the same. So I'm going to factor that out. 5a minus 7. And then what's left, my 4a squared and my 1, is going to go in parentheses as well. Now, it does not matter what order you write these in. It could be 4a squared plus 1 first, or it could be 5a minus 7 first. Either way, multiplication is the same forward and backwards. The last thing for part 1 of factoring is when we're going to factor ax squared plus bx plus c, and a is going to equal 1. So the number that's in this spot is going to equal 1. So as always, I want to check for a greatest common factor first. Okay. There is a greatest common factor with this. If I have x cubed, x squared, and x, I can pull out an x. So that's going to leave me with x squared plus 12x plus 27 when I do that. So I've factored out an x, divided out an x out of each term. So now this looks like this. I have a square term, I have a trinomial. My next is I want to focus on this c term. I want to focus here. I need two numbers, find two numbers that multiply to give you c. But then I need to focus on my b term. So they need to multiply to give me c, but those factors also have to add to give me b. So just starting out, go ahead and write 27 on the side and write what the factors of 27 are. You have 1 and 27. 1 times 27 is 27. You also have 3 and 9. Now, 3 times 9 is 27. If I add 1 and 27, I do not get 12. I get 28. If I add 3 and 9, I do get 12. So these are my two factors. So once I have my two factors, I'm going to go ahead and drop this into two sets of parentheses. Okay. My two factors are going to be towards the end. So this is technically the reverse FOIL method. So those are going to be each of my last terms in the parentheses. Then I'm going to look here at this sign. This is a positive and this is a positive. So both of these are positive in order for me to get 12. So I'm going to say those are my two signs. And then in order to get x squared, if I was multiplying, I would take x times x. So that's going to fill in here. Okay? So if you were to ever be unsure of yourself, you can always check your work. If I had x times x plus 3 times x plus 9, I'd first work on the inner. X times x is x squared. X times 9 is 9x. 3 times x is 3x. 3 times 9 is 27. Then, combine your like terms, x squared plus 12x plus 27. And if you multiply that x through, you would end up with what we started with. So this is a check. I would definitely check to make sure you would do the FOIL method by checking. Or, yeah, to check you would do the FOIL method. Okay. Let's look at this last example here. We have n squared plus 3n minus 54. So the first thing I want to do is check for a greatest common factor. Well, this is already in n squared plus bx plus or minus c. So this has no common factor. There's no common factor between n squared, 3n, and 54. I'm going to jump right to step 2 and say, look at my c term. Negative 54 is my c term. I need two numbers that multiply to give me that will add to 3. So 54, we can have 1 and 54. We can have 2 and 27, or 3 and 18, 4, 5, and then finally 6 and 9. So looking at all these, I need to be able to get positive 3. 1 and 54, definitely not. 2 and 27, nope. 3 and 18, no. 6 and 9. These give me a way to get that positive 3. In order to get positive 3, my 9 has to be positive, my 6 has to be negative. 9 minus 6 gives me a positive 3. So I'm going to go ahead and drop into 2 sets of parentheses. N squared, that means I'll have an N and an N. And then you can write these in any order as well. So N minus 6 times N plus 9, and you're done. That would be this trinomial completely factored. So it's like the reverse FOIL method. Your homework, there's a worksheet. It's titled Chapter 6, Section 4, Part 1. That is your homework for this lesson.